All right, we're back at it. Number two for the 2025 AP Calculus AB questions, the free response. We're going to jump right into it. Like I had told you guys from before, you are always expected to see functions, you're expected to see graphs, you're expected to see data tables. And in this one, we obviously see a graph. Very obvious as well right away. If they do shade it in, you're very likely going to be looking for area under the curve. Shader region R is bounded by the graphs of function f and g, where you have your function for your f and your function for your g shown in the figure. You can see right away you have the top and the bottom. So if we are, number one, looking for the area of R, show the setup for your calculations. So we know one of the points that we're going to be getting from this is going to be from the overall setup. We are looking for a definite integral, 0 to 3. You guys can see that right here is the bounds from left to right. And then we are setting up from top minus our bottom. Okay. And don't forget your dx. This is worth that point. All right. We do also need to make sure that we can set this up to find the actual answer. So as you guys can see, I've plugged that into our equation right here. For those of you that are new to it, if you are using your TI 83 or 84 under your math function, you can go down here to function integral to find this function for yourself. All right. So we plug that in 0 to 3, g of x minus f of x dx, and our answer is 5.1366. Okay. That's going to be your 2 points that are necessary for this problem. As you guys can see on the points and the scoring guidelines, we have to set up our equation. We got the point right there. We set up an answer for it in our calculator, and we get our 2 points right there. Number two, or B. Region R is the base of a solid. For this solid at each x, the cross-section perpendicular to the x-axis is a rectangle with height x and base in region R. Find the volume of the solid. Show the setup for your calculations. All right. Remember, anytime they say that, show the setup, right? You have to make sure that you show what your problem or what your equation is going to be. So we still have that base of our solid, okay, dx. But now we're going to be multiplying. Think of it this way. They're basically saying for each of these cross sections, you basically have a three-dimensional rectangle coming out of it, depending on what this is. So here we're just going to add an x in front of that. That's going to be our new function to use. And then we can obviously click equals in our calculator to find that. So here we've added the x into this function. In a lot of cases, you can just copy this function down, and what you end up doing is you use second insert right here, ins, second insert to add that x in the front of your function. Now, I want you to be careful here. Additional and extra parentheses never hurts. So I can see we have this function in here, and then we have this function in here. That's my G and my F. That's saved with, put together in terms of that part of the function, and I have my X in front of that there. The only thing that comes after this is basically the dx. Okay. So be aware that whenever you're in these functions, you have to be very careful to avoid making silly mistakes from not having the right parentheses around it. So jumping into our answer here and our check right here, we got our x added into that original function, making sure our parentheses are in the right spots, dx, and then our volume of this solid is 7.704, which as you guys can see, 7.704. You can round it up to 7.705 if you'd like. That's the same thing. You'll still get that point for B right here. All right, write but do not evaluate. That's very key right here. We do not need to actually find the answer for this one. An integral expression for the volume of the solid generated when the region R is rotated around the horizontal line of -2. All right. So what that means is right now we're looking at that -2 as the new distance to consider. And we have our outside function and our inside function. Now, this is a circular thing, so what we got to make sure is we understand outside minus inside. We want to start off and understand it's a pi with 0 to 3 of our function g of x minus the -2 to get that full distance right here. That entire equation now is squared, pi r squared minus f of x minus our -2 squared as well, dx. All right. So our full integral right here, that's all we need to do for this. This will actually worth quite a few points here because we have to make sure that we can set up the top outside of the function, the inside lower part of it, and not forgetting our pi as well. Let's jump into the answers right here. As you can see, the volume is pi of 0 to 3 of the g of x, the outside function squared, minus the f of x minus the -2 squared as well with our dx. Notice this, the response of only this earns all 3 points. Okay. You can also go ahead and distribute that negative into the -2. That still works as well. You are adding a distance of 2 to that function. So there we go. Let's get into that last one as well. Very last problem. We're making pretty good time on this. It can be shown that g prime of x, the derivative of this function is this, okay? 1 plus pi cosine pi x. Find the value for x for between 0 and 1 for x, at which the line tangent to the graph of f is parallel to the line tangent of the graph of g. Now that's pretty, it's kind of hidden within the wording, but when you see tangent lines, line tangent, what you're basically saying is that the derivative the derivative of this is equal to the derivative of the other. All right. Now I have a pretty, easy way to deal with this. The very first thing we need to make sure we do is because they did give us g of x already, right? G of x already has its derivative. We do have to derive this one very quickly. Power rule gives us a 2x minus 2. All right. From there, we're going to plug that into our calculator. We're going to go right into our our graphing tool. We're going to plug in the derivatives right there. So y1 is our derivative for g, y2 is our derivative for f. Our window we can set from 0 to 1 because that is exactly where they want us to look at, between 0 and 1. And when we graph that function, we see that they do cross at this intersection. So here's where I like to do. I hit second for calculations. We're going to go down to find the intersection of these 2 points. We're going to go to the left of the first one and the right of the second one. We hit yes to guess. The intersection is at 0.6758. All right, 0.6758. That is where the value of x of is going to have their tangent lines equal. All right. Let's jump back into the answer key. As you can see, D here, we set these two equal to each other. We set the equation equal to each other. Make sure you write this one out. Just setting this equal to each other is going to get you your point. As an answer, 0.6758, you don't have to go all the way down to the last digits. Usually they will accept 3 to 4 decimal points. If you're using a calculator, put as many decimal points in there. And that never does hurt. But at the end of the day, that is your answer. So your 2 points right there. Okay. That concludes number one and number two. If you didn't see number one is the video right before this. But that is your calculator section for Calculus AB free response questions number one and two. That's the end of part A. We did finish both of them well within the 30-minute segment. And again, part of it you will have to make sure you plug in your equations into your calculator. So make sure that you're quick with that. I would even just take some time and practice entering all of these equations that we have here into your into your calculator. Practice getting quick at that. Okay. And then making sure as well when you do have your answers that you are careful. For example, back in number one, making sure that you have the correct labels to answer with. And also, it never does hurt to box what you have as your answers. Okay. That's it. Number one and number two finished off for calculus AP, AB, free response questions for your calculator section. I will do 2024 and 2023 as well. You will have those ready too. But we're going to get into numbers three, four, five, and six, the non-calculator section, in just a little bit.